I'm Patrick Sullivan. I work for TELUS Corporation. I'm a program manager and a cybersecurity engineer. And I'm going to introduce the guys here. And this is an important question for everyone that's moving to the cloud, is how you do this securely. I support Exacta 360, which is a governance risk and compliance engine. And we've partnered with Amazon and the Enterprise Accelerator for compliance. We've got a presentation at 3:30 in room 207 down the other end of the hall. But what I want to do now is introduce Rob Barnes and Tom Ogilvie. They're going to discuss how you do move securely to the cloud. Thank you. Rob?
All right. So if you just had lunch, I guess that would make this dessert.
Nap time.
Nap time. All right, hopefully I'll keep you guys awake. So thank you. My name is Rob Barnes. I work in professional services for AWS, and I'll be joined by Tom Ogilvie. He is a principal software engineer at Blackbaud. So thank you for joining us for learning how you can plan for security, risk, and compliance when migrating to AWS. Now, if you'll allow me, I'm actually going to ask this a different way. Why should you plan for security, risk, and compliance before migrating to or are already using AWS? Now, this session is part of a migration track, but all the things that I'm going to be talking about apply to customers who are already using AWS. So if you haven't moved yet, it's much easier to plan for your security, your risk, your compliance before moving. Because it's much harder to retrofit security controls into an existing infrastructure. So I don't swear a lot, but when I do, it's meaningful. And I'm saying this because most of what we're going to talk about in this session can be distilled down to one 4-letter word. And I'm going to be using that word a lot. So I apologize in advance if you have sensitive ears. That word is risk. Risk is the Murphy's Law of information security. What is Murphy's Law? If something can go wrong, it will. Or as a colleague of mine pointed out recently, what it really means is that things will always fail, so plan for them. So the historical definition of risk from an information security perspective is that it is the product of the likelihood of something going wrong and the impact to your organization when that thing does go wrong. So your risk at your organization might be different than somebody else's risk. If you're a government agency, threats to the confidentiality of your data might be key risk factors. If you are a federally funded research institution, then threats to the integrity of your data might be key risk factors. If you are a large internet retailer, threats to the availability of your system might be key risk factors. If your system goes down and you are a large internet retailer, the impact to your organization can be measured by the loss of income, the loss of revenue. For a nonprofit organization or a non-government organization or at public sector, your risks can be much different. If you're involved in disaster relief and there's a natural disaster that strikes somewhere, and your site is flooded with people wanting to donate, and your system goes down, maybe it can't handle the flood, or there's some sort of malfunction and the system can't accept donations, then your nonprofit organization can't accept the donations, which means that your organization doesn't have the funds to buy the supplies to help victims of a natural disaster. So the impact to your organization then isn't measured in loss of revenue. It's measured by your inability to help the victims of these natural disasters. And worse, it could be measured by loss of life. So if you own risk in your organization, or if you in any way contribute to risk management in your organization, which, by the way, includes everybody here then you don't lie awake at night thinking how secure you are. You don't lie awake thinking how well things are going. You lie awake thinking of what can go wrong. So fortunately, though, when migrating to AWS, we provide you the services, the features, the capabilities, the insights for you to have into your infrastructure so you know that security controls that you have in place, perhaps they're to meet compliance requirements, are still intact. And the question is, can you say that before you migrate to AWS? Can you say that about your current infrastructure? So how do you do that? It's useful to think of a risk management framework that begins with directive controls. So these are your risk-based requirements. If you're a government agency and you have to comply with FedRAMP, then these would be your NIST 800-53 risk-based requirements. If you manage credit cards, if you process credit cards, if you think about credit cards, then these are going to be your PCI, Data Security Standard, risk-based requirements. Perhaps you have your own organizations, your own organizational risk requirements. For example, Tom's going to talk here in a little bit. When I worked with him on their payment service, he said, I'm not interested in checkbox compliance. Yes, we need to meet PCI requirements, but that's not good enough. I want to go above and beyond what PCI says I need to do. I want to go above and beyond what PCI says is secure enough. So these are all directive controls. These are the thou shalts. Thou shalt segment your network for sensitive workloads. Thou shalt encrypt your data at rest. Thou shalt incorporate the principle of least privilege. So now that we have our risk, there's that word again, cover your ears, or your risk-based requirements, you can now start to implement those into your preventive controls. So your preventive controls are the specific AWS, in this case, security controls that map to your risk requirements. So these are your network segmentation security rules. These are your encryption at rest controls that satisfy your risk requirements. These are your user policies that enforce the principle of least privilege. What's nice about this is that once you've mapped your risk-based requirements, you can map those to specific security controls. I have a network segmentation requirement. Here's my specific security control. So then you can start to see then, here are my requirements, here are the specific controls that meet those requirements. And vice versa. For every security control, you can map those back to a requirement to justify the existence of that control, and also to understand if you change that control, what impact does that have on your compliance? So now we've established, or we've begun to establish, our governance baseline. We have our requirements, and now we have our implementation. We have those specific controls, and that's good. So today, you implement these controls, and you can say with authority that my infrastructure complies with my risk-based requirements. So maybe you sleep a little bit better at night. But what happens tomorrow? What happens the next week, the next month? Can you still say authoritatively that your infrastructure still complies with your governance baseline? Maybe with a lot of this. So that's where that's where detective controls come in. So if your security controls change, you want to know about it. One of the ways you know about it is you log what happens. So when I talk to my customers, one of the things I ask about detective controls is, what do you want to log? What answer do you think I get? Everything. everything is knowable. Everything is really hard to document. Everything is really hard to test. So we don't have a directive control that says log everything. In order to do that, I need to understand what my log sources are. So in AWS, maybe then we can start with AWS service-related activities. So anything that occurs in my AWS account that's service-related, I want to record that. I want to log that. Maybe I want to log my intra-network traffic so I know what's happening within my network. Or if I have a web application, maybe I want to log all of the web requests coming in to my web application. So that's a start. So I'm starting to define very distinctly what my log sources are. And if I didn't have directive controls initially, well, I can start defining those now. If I don't have those requirements before migrating to AWS, those are things I can start documenting. I want to log these AWS service event calls. I want to log my network traffic. Those now become my directive controls. So this is cyclical. So now this is good. So now I'm logging these things. Is that good enough? So what good is it if I log that one of my network segmentation control fails or is changed? I can log it. But some of my controls are maybe more sensitive than others. If a control that's changed violates my compliance status, whether it's NIST 800-53 or PCI or my own organizational risk requirements, if that control fails, that puts my compliance status in jeopardy. So if that thing happens, then that's the thing I want to look for. I can log everything, or all the things I've identified, but I want to monitor for specific things. So if my network segmentation controls change, I want to monitor for it, okay? I'm monitoring for it. Now what happens when that thing happens? I want to do something about it. So traditionally, what happens, well, maybe I'll notify my Network Operations Center, my NOC. And if there are any NOC employees in here, they're probably getting ready to hit me on the head with a rubber mallet because these guys get notifications all the time. It's noise. And if this network segmentation security control changes, and I know that that change will violate my compliance status, and if I know that in every case, if that control changes, if I am going to respond to that the same way every time, and that change will be, or that response will be to change that thing back. For example, if somebody opens up an insecure firewall rule, if my response will, in every instance of that happening, will be to remove that firewall rule, well, I want my system to take care of that for me, right? So now I'm identifying my responsive controls. My response might be to send an alert. Maybe that's not good enough. So now, with AWS, if a change happens to one of your preventive controls, you're going to log it, you're going to monitor for changes, and in specific cases, your system will detect that that change is critical enough that you want to auto-mitigate what happened. So the system will take that control, revert that change back to the last known good state, which is good. But because we're logging everything, the system also knows who made that change. And maybe the change was made by an authorized staff member who maybe made the change outside of a formal workflow. So now you want to, or maybe his credentials were compromised and somebody's in your network making changes. So the system now can not only revert the change, but now the system can revoke the permissions of the user who made that change. Then you can send a notification to your NOC saying, this thing happened, don't worry, I got it, I fixed it, I changed it, and I revoked the privileges of this person, but you might want to go follow up with this person to see if that change was made intentionally and follow up and understand why that change was made. So these are our responsive controls. How do I define what my responsive controls are going to be? It depends. It depends on the criticality of the security controls, and that's really defined by my organization. Then those are fed then into your directive controls. All right, I want to create a network segmentation security control or set of controls which are implemented in AWS services. I want to log for those changes, or I want to log changes, I want to monitor for those changes. Now I want to auto-mitigate them. All right, so now I'm creating requirements as I'm doing this. But it's important to understand as we're going through this, it's not a serial process. I'm not doing one, and then the other, and then the other. All of these types of controls, the directive controls, the preventive controls, the detective controls, the responsive controls, they're interrelated. So it's useful to think of them in control areas. For example, let's say you're going to migrate a workload to AWS. So you have an account, there's nothing in it. What controls are you going to stand up? Well, I know I'm going to need a network, but if I'm going to stand up a network, I need somebody to do it. Okay, what does my network look like? Well, I'm going to create a policy that's going to give privileges to a certain group of users, maybe my network administrators. Okay, so now I'm talking about controls, and now I'm talking about users. Okay, so that's an integration point. So I have controls that I'm going to create. I'm going to provision users and groups and attach a policy to those users and groups that allow them to make changes to my infrastructure. So this is done concurrently. But that policy is going to allow them to do very specific things. It's going to allow them to create my network infrastructure, perhaps modify the network infrastructure, maybe or maybe not delete elements of that network architecture. It's not going to let them create an application. It's not going to let them create IoT devices. That's not their role. So we're creating a policy that incorporates the principle of least privilege. So now I'm meeting my compliance requirements. So I've got users, I've got policies now. They can make changes to my infrastructure. In this case, we're creating a network infrastructure. But remember, now we're logging changes to my infrastructure. So I've created these controls. Those controls then get logged, or the creation events or modification events of those controls get logged. But wait a minute. I think I have risk-based requirements to encrypt my data at rest. Okay, so now I need to create my data protection requirements. Well, what are those? Well, that includes potentially encryption. Okay, well, how do I generate my encryption key? So, okay, that sounds like a requirement. How often do I rotate my encryption key? Who has access to that encryption key? Who can encrypt data using that key? Who can decrypt data with that key? So now all of a sudden, I'm introducing new requirements based on my data protection risk-based requirements. Oh, and by the way, since we're talking about logging changes to the environment, how long do I keep those logs? What do customers usually say when I talk to them? How long do I keep logs? Forever. Forever is a mighty long time, let me tell you. There's a cost associated with logging forever. So maybe my log retention policy or my data retention policy needs to reflect something a little more reasonable. If you're PCI compliant for your car data environment or data relative to your car data environment, it's 90 days in hot storage at a minimum and at least a year up to cold storage. That sounds like a directive control. That's a risk-based requirement now. And if you don't have a data retention policy now before migrating to AWS, sounds like a really good opportunity to develop that now as you're migrating. It's a lot easier to build those controls in now than to retroactively. You can do it. You can retroactively change or incorporate these controls, but it's harder. Okay, so now I'm encrypting that data. Now I need to grant users the ability, certain users, the ability to read those logs. Well, those logs are encrypted, remember? So now I need to grant access to those users to decrypt data using the same key that was used to encrypt the data. So again, this isn't serial, one thing after the other, after the other. All of these things are being done in concert. And now, since I'm logging changes, and I'm monitoring for certain events, well, something just happened that I had a requirement for to detect and to monitor for. That could be a potential incident because a security control changed that was unexpected. And if that change represents a drift from my governance baseline, then guess what? Oops. I'm changing that thing back. So that's my incident response capability then, is this auto mitigation. And not only am I going to change that thing back, here's where I revoke the user's policy so he can't make that change again until I follow up with him. So all this is good in theory. These are things that you need to do in advance of migrating to AWS. It's much easier to do it in advance. What I'd like to do now, though, is invite Tom Ogdenben up on the stage, who can talk very specifically about the good work he's done.
Thank you, Rob. Good afternoon, everyone. I get to, there we go, perfect. Hi, my name is Tom Ogdenben. I am a principal software engineer at Blackbaud. I have about 30 years of experience developing payment applications, and 24 of those have been at Blackbaud. However, in the past 10 years, I have been focused on our payment solutions. Now, when we first started working on this application, there were very few people at Blackbaud who were aware of PCI. We knew it was important. I think we just kind of failed to grasp how much effort was going to be involved in order to implement it. So my work on that project made me much more security aware and risk adverse. And I've often joked that complying with PCI compliance is akin to the 5 stages of grief. And I have counseled many programmers and product managers from the initial denial to the final acceptance. And many of those conversations revolve around security. Today, though, I wish to talk about the journey that we've taken to migrate that payment application to the cloud. Some of the reasons why, some of the questions we asked, and more importantly, some of the answers we chose. Hopefully, providing you with some additional insights so that your own journey can be just as successful. But first, a little bit about Blackbaud. We're a company that works with nonprofits. We were started in 1981 with one product supporting one customer, growing to become the world's leading cloud software company powering the social good. We're headquartered in Charleston, South Carolina, and we have over 18 offices worldwide. We serve over 35,000 customers in about 60 countries. And with the rise of peer-to-peer fundraising, that 35,000 can easily grow to 350,000. Now, as I've mentioned, I've been working on payment applications, and in fact, I developed most of this solution. In the past, Blackbaud has had many products and many applications that have processed credit cards. There was never any consistency to it, how they did it, and admittedly, some were better than others at protecting cardholder data. In 2009, I started work on a hosted service called the Blackbaud Payment Service. This is a web service that our applications can use to securely process credit card and direct debit donations. It was built to standardize how Blackbaud handles credit cards and how our applications process them. It was also built to reduce our clients' PCI footprint as we would migrate cardholder data, which was stored in our applications running on our clients' networks, into our web service. And of course, it was built and deployed with PCI in mind. And it runs in our own data centers, and it has all the infrastructure you'd expect. Web servers, database servers, firewalls, VLANs, a litany of SIEM solutions. And we have good muscle tone on maintaining and monitoring this service with a low operating cost per client. And we've seen a steady growth in the number of clients using the service over the years with cyclical peak demand usage. And so, with a fairly successful deployment, good ongoing operating procedures, that we meet our compliance year over year without any problems, why migrate? Why move? Why go to why AWS? We have a good disaster recovery story. We're running in multiple data centers. However, AWS provides multiple availability zones that are really easy to use. And if you stand up your services in just 2 of those zones, you can get an SLA of 99.95%. And we can handle the current demand. But what about the future? As Blackbaud expands globally, we expect our solutions to expand with it. Well, AWS is already in the regions that we want to go to assist us to help our clients build more hospitals, feed more people, protect more resources. And we have the tools in place to protect our assets. We have teams who can respond to both security and infrastructure-related events. With AWS, though, we can consolidate and standardize our SIEM solutions for all of our hosted applications, and not just those in AWS. Its IAM policy and account isolation allow us to separate our application environment from our SIEM environment. Its AWS security groups helps us ensure us that our system components only communicate with the system components that we want them to. AWS Config and CloudTrail can track changes to resources and who made them and alert you when something unexpected happens. The immutable log data provided by those services can be delivered to the SIEM provider of choice. We know how to build and configure infrastructure. Well, with AWS, we can build it faster. With its robust API, we can use automation, which I think is important when you're building, configuring, and maintaining secure environments. For example, if you want your EC2 instances to be built using only your approved AMIs, well, use automation. Or you want to make certain that those EC2 instances are attached to specific IAM roles based off of the function of that EC2 instance, well, use automation. Don't rely on hoping that someone selects the right value in some dropdown in some web GUI. If you remember that earlier graph that I showed that had the cyclical peak usage, well, today we have the infrastructure in place to support that. Well, the problem is it's running all of the time, even when we don't need it. With AWS, though, it's easy to add and remove infrastructure as your demands need it. And if you have a problem with an EC2 instance, don't fix it, replace it. Automation can help you configure and maintain a strong security profile in your AWS networks. For example, sorry, I'm a programmer, so we're going to see some code. Sorry. We wanted to completely define our networks. So we used the AWS PowerShell API to completely remove the default VPC and its related artifacts from each of the regions. So we include this code snippet in our orchestration code. And thus, we can build our VPCs and our networks with our preferred network segmentation. Because I personally think a good security principle is to remove something or disable it if you don't need it. Running data centers is not easy or cheap. But with AWS, We no longer need to worry about amortizing hardware purchases or maintaining 24/7 support contracts with vendors. We can focus on our core mission of providing software and services to empower and connect people to advance the social good movement. We know we want to move to the cloud, and we know that we're going to move. Is AWS the place? Is AWS the answer? Now, the previous slide seemed to imply that it is, but before we got there, we had to do our due diligence. Is the cost reasonable? Does the provider have a proven track record of handling secure workloads? What challenges will we face meeting our regulatory requirements? Is it performant? These are the types of questions that we had to answer pretty early in our pipeline. And to answer the performance question, we actually ran our benchmarks in AWS and compared it to our current benchmarks. Now, this meant that we had to stand up the application in AWS, which actually answered another question. Is it technically feasible? Will our custom application run in AWS? Now, we stood this up, but it just had minimal security solutions in place. It wasn't production ready. We weren't going to make the mistake of taking this and making our production environment. We were just planning on throwing it away. And of course, to do this, we had to have some knowledge of the AWS technology and how it all worked. But we put time in our schedule for that. What type of migration would we do? A lift and shift involves moving your current ecosystem into the cloud. And I've read case studies where people have taken their entire VMs and just dropped them right into their cloud provider. Or would we take this opportunity to completely rewrite this product and deploy that new application into the cloud? And this is actually an approach that another team at Blackbaud did. They rewrote their application as they were migrating it into the cloud. We took a lift and shift approach. We would use new infrastructure and networking segmentations, but our application and our database schema wouldn't change. And we would take advantage of updated operating systems and configurations. And we would reevaluate our current SIEM solutions and pick those best suited for the cloud environment. Well, what would our ecosystem look like? How many environments? Should we separate the application environment from the security environment? Well, we know we wanted separation. We have a security operations team that can respond to security events. But I wouldn't want them to have the ability to be able to change the application. And likewise, those people responsible for the application, we didn't want them being able to change our SIEM environment. Now, we could have used AWS support, our AWS support for RBAC implemented with IAM policies and roles. We decided to go the route of separate AWS accounts. And we wanted to use that security environment to monitor all of our hosted applications, and not just those in AWS. This represented a fairly big change of scope for us, because now we weren't just moving one application, but we were building an entire new SIEM environment. Blackbaud's security engineering team would be responsible for that, and my team would provide them with assistance. Well, who's going to access the environment, and what are they going to do with it? Blackbaud has an operations center that is staffed 24/7, and that team is responsible for monitoring the health of the environments as well as performing common routine maintenance. Well, I wanted to extend their role to include this environment. What playbooks will they need for success? And I'm not talking IAM roles here, but something more generic. The specific policies and the level of access would come much later. Blackbaud is driven to implement software-defined infrastructure where it's appropriate. We want to codify all that tribal knowledge into a repeatable, testable process. Because if everything is software-defined, then your infrastructure can be placed in source control. And changes can be tracked, and they can be code reviewed before they're deployed. And you can use that software to build as many environments as you want. Build a test site. At Blackbaud, our test site is an exact copy of our production site, including all of the security controls. And we use that to evaluate any changes before they get deployed into production. Sounds a lot like just classic project planning, because it is. But it's important to ask the right questions and that you schedule time to complete those discovery items. Consider maintenance. You're going to spend a lot of time designing and building for day one. What about day 100? How are you going to take advantage of new AWS offerings? How do you want to update your application or update your solutions? How do you want to extend that? We want to leverage our existing teams, and so we made sure that we gave them the tools so that they could be successful. It's a big project. I was not going to do it alone. And my team, there's only 3 people on the team. Now, I haven't really mentioned the AWS technologies yet, but getting familiar with the AWS technologies was probably one of the harder things I had to do. There are a slew of services, and not all are available in all regions. And even a simple web page that lists all of the services just underestimates the total number of features that are available. And just when you get comfortable with something, AWS introduces something new. I'm not complaining. Keep them coming, AWS people out there. We need them, but we have to stay on task, and we'll evaluate them and implement them if it makes sense in our current pipeline. Like, for example, AWS introduced the application load balancers, but they came after we had already coded, implemented, and tested our solution using the classic load balancers. It would have been too disruptive in our schedule to replace those load balancers with the new application load balancers. Now, not to say we won't use them in the future, but we'll plan a discovery task around it. Version 1 of our infrastructure, though, it's released with the classic ELBs. Systems Manager Service, on the other hand, was introduced before we had developed our playbooks for managing our internal users. So I evaluated it and determined that it fit. And in true SDI format, I've automated the SSM document deployment. So now all of our SSM documents are kept in source control, and changes to them are reviewed by another team member, and CloudShell will record that the document was updated, and our existing IAM policies will ensure us that the right role, and only the right role, has access to execute them, but they can't change them. So where did we end up? Well, we certainly approached the project with a security-first mentality. Security was not going to be something we were going to bolt on in the end. It was not going to be a business-as-usual activity, because I personally feel that if you have good security, it can actually help you with meeting your compliance requirements. We didn't start from scratch, and some requirements were already defined for us. As I mentioned, Blackbaud is relentlessly driving towards standardization, and this includes infrastructure. I had mentioned that other team that had rewritten their product was part of their migration story. Well, as part of that work, they had actually designed a network segmentation scheme that I wanted to take advantage of. More importantly, though, they had also written a software library. And so we took that library and added functions specific to AWS. And so using a combination of CloudFormation templates, Lambda functions, and the AWS PowerShell API, we built our infrastructure. And then we used their code to transform that generic EC2 instance into the IIS web server. I reviewed the PCI Quick Start guides that are available on the AWS documentation site. We reviewed and implemented the CIS AWS Foundation's hardening standards. We try to avoid the use of IAM users, and instead we rely on the SAML support built into AWS for single sign-on integration linked to our corporate networks. And we make heavy use of IAM roles and custom policies. We deliver CloudTrail, AWS config, and VPC flow logs to our SIEM environment, where they are analyzed, aggregated, and stored. We enable EBS volume encryption using our own KMS keys. We are very restrictive on our security groups. We have a well-defined network, and we make certain that our DMZs only contain load balancers, and we use the various SSL policies to protect our clients' data in transit. And we use VPCs and VPC peering to connect our environments. And of course, all of our configuration data and all of its code is maintained in our source control system. And we use automation to quickly and securely deploy changes. Today, we have completed our PCI assessments. And by the way, a lot of that collateral is collected with automation. We've engaged with a third party to conduct multiple external penetration tests. And for logistical and business reasons, we have decided to migrate 2 additional complementary payment applications, and that work has just started. But the cool thing is, once we added those EC2 instances for those applications, they are automatically being monitored by our SIEM solutions. And lastly, I want to leave you an example of how we used automation to solve a security vulnerability. So an early penetration test have revealed that we had a vulnerability. We had the SMB v1 protocol enabled. We didn't need it, so I wanted to remove it from all of our current and any future servers. And to remediate that, I just need to execute these 3 lines of PowerShell against all of my servers. So I ran it in our test environment. I measured and validated its impact. Then I deployed it across all my servers in my production environments. The time from when we identified a solution to successful deployment in our environments across all relevant servers was less than 1 hour. And of course, as everyone knows, the SMB v1 protocol gained notoriety a few weeks ago for its role in the WannaCry malware. Thank you.
Thanks, Tom. So what you've just heard was a success story. So I was thrilled when Tom agreed to come up and present with me today, because what it demonstrates is that, especially with what Tom outlined, is that a deliberate planning for a migration is critical to be successful in AWS, as opposed to taking what you have now and putting it into the cloud. It takes careful consideration for taking your risk-based requirements and other organizational requirements in advance to ensure success. And one last thing that I'll lead you with is that when I talk to customers about moving to AWS, I don't start the conversation with security groups and firewalls and IAM policies. I talk to them about their risk and the impact to their organization if something goes wrong. If they can't meet their objectives, what is the impact to them? And more importantly, think of the natural disaster. What is the impact to your customers if something goes wrong? And I'll leave you with that. Thank you, everybody. Please submit your surveys either on the app or outside as you leave, and let us know what you think. Thank you.